In this video, we're going to solve linear equations with fractions. Remember, linear equations are equations that are first degree. So let's look at this one. This one doesn't have fractions in it, but we'll do this one to start. And our next one will include a fraction. So we'll solve 6 times the quantity x minus 3 plus 10 times the quantity x plus 8 equals x plus 43. So to begin, we'll distribute the 6 and distribute the 10. Remember, when you're solving a linear equation, usually you simplify each side first. There isn't anything to simplify on the right, but on the left there certainly is. So let's distribute, and we'll get 6x minus 18 plus 10x plus 80 equals x plus 43. And then when we combine like terms on the left-hand side, we'll have 16x plus 62 equals x plus 43. And now we want the expression to have the equation to have the variables on one side and the constants on the other. So let's subtract x from both sides. So if we do that, when you first learned to solve linear equations, you probably wrote that minus x on both sides. But at this point, we don't need to. You can do that in your head, but you can write that down if it helps you. So we would have 15x plus 62 equals 43. And now we'll subtract 62 from both sides. And again, I'm writing this minus 62, but I won't on every problem. So we're subtracting 62 from both sides, and we'll have 15x equals negative 19. And when we divide both sides by 15, we get x equals negative 19/15, and this problem is done. When you're showing your work for solving linear equations this way, I would want to see all of the equations working down the page, all of the equivalent equations. So that means the original problem will be written down, and then you'll have this next line and the next equivalent equation, but you wouldn't necessarily write those minus x's that I have written there. And similarly, you would write this equation, but you might not write the minus 62. So you just generally work down the page until you get to your solution. Let's solve another one. So for this next linear equation, we will include a fraction. So the example will be this: x over 13 plus 2 equals negative 1. And there are a couple of different ways to solve this problem. We could subtract 2 from both sides, so let's do that. When we subtract 2 from the left-hand side, we just have x over 13. When we subtract 2 from the right-hand side, we have negative 3. And then we have an x divided by 13. So to undo that division of 13, we're going to multiply by 13. And of course, that means we need to multiply both sides by 13. So the 13's cancel, and we have x equals negative 39. But suppose you looked at the equation initially and decided you wanted to clear out the fractions right from the beginning. That is also a possibility. So let's solve it again a little bit differently. So we'll have x over 13 plus 2 equals negative 1 again. And we are going to clear out the fractions on the first step. And we're multiplying both sides by 13. And our multiplication property of equality says that's totally fine to do. Anytime you have an equation, you can multiply by anything you like, as long as it's not 0, because multiplying both sides by 0 would wipe out the sides. So I'm going to multiply both sides by 13 right now. But notice I put parentheses in because you would need to make sure each term got multiplied by 13. So it really looks like this. Let me rewrite the equation. We distribute that 13. So the 13 gets multiplied by each term on both sides of the equation. And I would then have x plus 26 equals negative 13. And now to finish, we subtract 26 from both sides and we have x equals negative 39. And notice we have the same result either way. And you might look at this and think, well, the first one looked a little bit simpler. Well, on this particular problem, there wasn't a huge benefit to multiplying by 13 on the first step. But on some more complex problems, I find it beneficial to clear out the fractions. You don't have to. You can always decide whether you'd like to work with the fractions or clear them out when you have an equation. So let's do this next example. The directions up at the top still say solve, so we will look at this equation. 1 minus x over 5 equals 4x plus 2/3. And as I mentioned, you don't have to clear out fractions. You could look at this and just decide to add x over 5 to both sides to get the x's on the same side. But I'm looking at this thinking it would be easier for me if I did clear out fractions. So you look at the least common multiple. That is, you're looking for the smallest number that both the 5 right here and the 3 right here go into. And the smallest number that 5 and 3 both go into is 15. So we're going to multiply both sides by 15. It's a common mistake for people to choose to multiply one side by 5 and the other side by 3. But remember, it is only valid if you multiply both sides by the same number. So when we distribute the 15 on the left-hand side, we'll have 15 minus 3x. And when we distribute the 15 on the right-hand side, we'll have 60x plus, let's see, our 3 cancels, and we have 5 times 2, and we have 10. And now we have a simpler looking linear equation. We need the x's on the same side. You can choose to subtract 60x from both sides or add 3x. I'm going to just choose to add 3x to both sides. And again, this plus 3x that I'm writing here is just for clarity to show you what's happening, but you don't actually have to write that part that I wrote right there. You do need to write the next equation, though. It is 15 equals 63x plus 10. We subtract 10 from both sides, and we have 5 equals 63x. And we divide by 63. So we have x equals 5 over 63. And this equation is finished. Let's add a little bit more to the next problem. So here's our next example. It is 6x plus 7 over 11 equals 2 minus x plus 4 over 3. As with the previous problem, I find it easier to clear out fractions. So that's what I'm going to do as my first step. And we look for the least common multiple, the smallest number that 11 and 3 both go into, and that's 33. So we're going to multiply both sides by 33. That means each term is multiplied by 33. So I'm going to multiply by 33 here, multiply the 2 by 33, and I'm going to multiply this expression by 33. And notice I was really careful about where I wrote that 33. It was in the numerator because remember, when you multiply by 33, it is really 33 over 1. I just often choose not to write the over 1 part, but I'm still very careful about where I write the 33. It makes it a little bit clearer about what's happening. So now when we do the reducing, and that is, of course, the whole point of multiplying by 33, we get a 3 on the left side. So on the next step, I'm going to be distributing the 3. On the right-hand side, I have a 66. And I need to do more reducing here. The 3 and the 33 cancel, and I have an 11. So on my next step, I'm going to be distributing a negative 11. And let me point out that here, right here, is a negative sign, and that needs to be distributed. Not distributing negative 11 is a common mistake. So if we do our distribution, we'll get 18x plus 21 equals 66 minus 11x minus 44. It is possible to bypass the second line that I have written. In fact, go from the first equation down to this equation. But I find that often people make mistakes if they do that, if they haven't practiced the problems a considerable number of times. If you're comfortable with leaving off the intermediate step, you could go straight to the third line I have written there. But if you find you're making mistakes, I would encourage you to write that intermediate step. So let's continue. I'm going to combine my like terms. So I have 18x plus 21 equals negative 11x plus 22. I need the variables on the same side, so I'm going to add 11x. Subtract 21. And divide by 29. And we have the equation finished. Let's solve another one. Let's look at this next problem. It's going to be 6 minus 4x minus 1 over 3 equals 3/4 times x plus 5 minus 2. Now, there are a couple of different ways to handle it. Sometimes people like to distribute this 3/4 right here first, because somehow the parentheses throw them off a little bit. So I'm going to do that first, and then we're going to start the problem again a little bit differently. So let's separate the terms on the right-hand side by distributing that 3/4. So I will have 3/4 x plus 15/4, and then I still have minus 2. Now, since I am looking at individual terms, I could do something similar on the left-hand side. I didn't do it on the previous problem, but that's okay. You have options when you're solving equations. So on the left-hand side, I have 6, and I still have to take care with this negative sign right here and make sure it gets distributed. But I'm going to apply this 3 in the denominator to each of the terms of the numerator. So it would look like this: minus 4x over 3 plus 1/3. Again, that plus 1/3 comes from the fact that I distributed the negative in front. So sometimes people like this better because it's a very clear, the individual terms need to be multiplied by that least common multiple. And that number is, of course, 12. So I'm going to multiply the left-hand side by 12 and the right-hand side by 12. Again, make sure you multiply both sides by the same number. If you prefer to write the 12 next to each individual term, that's possible as well, and often people do that. So give me a chance to write this line. So we'll put the times 12 next to each term, and then we'll make sure we haven't overlooked any of them. So we need to make sure we do the canceling when we get to the fractions. So we have 72 minus, the 3 and the 12 canceled, so we have minus 16x. The 3 and the 12 cancel, and we have plus 4. Now we have 12 times 3/4 x. That gives us a 9x. And then we have a 4 and a 12 that are going to cancel. So we have 45. And then the last term we have a 24. So when we combine like terms, we have 76 minus 16x on the left, and we have 9x plus 21 on the right. So to finish, we need the terms with the variables on one side and the constants on the other. So I'll add 16 to both sides, 16x, and we'll have 25x on the right. And we'll subtract 21 from both sides, and we'll have 55 on the left. When we divide both sides by 25, we'll then have x equals 11 over 5, because we need to reduce that 55/25. And the equation is finished. But I want to take you back to the first line, right up at the beginning, when it was 6 minus 4x minus 1 over 3 equals 3/4 times x plus 5 minus 2. Instead of distributing, we could decide to clear out fractions right from the first step. Notice there's a common factor, the least common multiple would be 12. So we're going to multiply by 12. So I'm going to multiply the 6 by 12. I'll multiply this expression by 12. And here is where you need to take quick care. This 12 is being multiplied by the 3/4 times x plus 5. I do not need an additional 12. Often I have people multiply the 3/4 by 12 and the x plus 5 by 12. But that's too many 12s, as I'll show you in just a minute. So we're going to multiply the 2 by 12 as well. So let's continue. So we'll have 72 minus, now let's do our canceling. The 3 and the 12 cancel, and we have a 4. So we'll distribute on our next step. Now, on the right-hand side, the 12 will be multiplied by the 3/4 right here. And when we multiply 12 by 3/4, we get 9. The 9 will then get distributed to the x plus 5. So in that way, the 12 does actually get applied to the x plus 5. That will happen on our next step. And we have a minus 24 on this line. So when we distribute, we'll have 72 minus 16x plus 4 equals 9x plus 45 minus 24. And notice that is the same as this line on the left-hand side. They're completely equivalent. So me personally, I prefer to solve an equation as it is on the right-hand side. I like that strategy best. But you can solve an equation however you like, as long as you don't break any of our rules of algebra. If you prefer to solve it on the left-hand side so you can see individual monomials instead of having a number to be distributed across a binomial, that's your choice. Let's do one more problem. And in fact, I'm going to write one. It's very similar to this. And why don't you pause the video and give it a try yourself? And then I'll go through it and see how you do. So here's the problem I'd like you to solve. It is 4/7 times the quantity 6 minus x equals x minus 8x minus 1 over 2. And again, pause the video, give it a try, and see how you do. Okay, now I'm going to solve it. We look for the least common multiple. With 7 and 2, the least common multiple is 14. So I'm going to choose to multiply by 14 on the very first step. If you distributed the 4/7 first, and on the right-hand side, you chose to apply the 2 to both the 8x and the -1, and you were careful about distributing the minus that's in front of that fraction, that's totally fine. Let's see if we get the same results. So I'm going to multiply by 14. So I'm going to multiply by 14 here on the left. Remember that 14 will apply to the entire expression on the left-hand side of the equal sign. And then we'll multiply by 14 here and by 14 here. So when we do our canceling, we will have a 2 that is multiplied by the 4. That gives me an 8. That will multiply by 6 minus x on the next step. And we have a 14x, a minus. Now let's do more canceling. And we'll have that 7 that needs to be distributed on the next step. So on the left-hand side, we have 48 minus 8x. And on the right-hand side, we have 14x. And again, make sure we're distributing that -7. So we have minus 56x plus 7. Were you careful right here? Did you have a plus 7? That is the most common place for people to make a mistake on this problem. The other place is sometimes people aren't careful when they're multiplying these two numbers together. They overlook one of them. Did you have an 8 right here? Okay, let's continue. Now we'll combine like terms. So on the right-hand side, we'll have negative 42x plus 7. On the left-hand side, it stays the same. Let's see, our choices are to add 42x or add 8x to both sides. I think I'll add 42x. If I do that, I'll end up with, what is that? I'm adding 42. That would be 34x. Now we'll subtract 48 from both sides. Oh, I lost my pen. So 34x equals negative 41. And we divide by 34. I hope this problem went well for you.